So I'm going to talk about how to solve this problem, search in a rotated array. So the first question, what is a rotated array? So let's say there is a sorted array, which is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This is a sorted array. So if we rotate this array clockwise by 2 steps, we can get R1, which is 7, 8, 1, 2, 3, 4, 5, 6. And if we rotate this original array counterclockwise by 2 steps, we got 3, 4, 5, 6, 7, 8, 1, 2. Okay, so the aim of this problem is to search a target value, let's say 6, in the array. So if the target value is in the array, we return the index of it. If it's not found, we return -1. So naively, the naive approach is just compare the target value, compare the target value 1 by 1 to the elements inside array. But for this approach, the type complexity is O of n is a little slow. So we know that if we want to search a target value in a sorted array, there is an approach called binary search. So let's see if we can use binary search to this problem, to this rotated sorted array. So let me use another expression to show what is a rotated sorted array. Okay, so the original array is like this: 1, 2, 3, 4, 5, 6, 7, 8. The length of these stakes represent the number. Okay, so if we rotate this, this array, it's like to move the former two, the last two in front, right? It's like this, and this is R1. And if we rotate counterclockwise, counterclockwise, what we got is like this, okay, and this is R2. So let's see if we can apply binary search to this rotated sorted array. So if we cut the array in the middle, so there are going to be two circumstances, right? Two circumstances. The first situation is like the value in the middle is the value in the middle is less than the value in the end, right? So the first one is mid value is less than the end value. So the second scenario is like the mid value is larger than the last value, the end value, right? So the second circumstances is mid is larger than the end value. Yeah. So after we separate the array into two parts, and one of them should be a normal solid array, like R1, the right part, the right part of R1 is a solid array. Right? If the target value is inside this range, we just use binary search to this part. So similarly for R2, so if the target value is inside the left part of this array, so we can use binary search. So if not, so we can recursively call this function to search the left side of R1 or the right side of R2. This is the basic idea of this approach. Yeah, so this is a recursive function. So for recursive function, the most important part is to know when to stop it. When to stop recursion. So there are only two results, right? Found or not found. So the first one is like the start index is just like the binary search. The start index is larger than the end index. That means not found. Not found. We return -1. So if the mid value, is just equal to the target, means found. That means found, and we return the mid. Yeah. So similar as binary search. So each round we separate the array into two halves. That means there at most log n rounds. So after log n rounds, either we found the target value, or we cannot find it. We cannot find it. So the time complexity. So the time complexity of this approach is O log n. Okay, that's all.